Hi everybody, in this video we are going to finish up that topic of factors and primes. So the topic that we just kind of wrapped up on page 9, we need to finish it. And so we are going to talk about factoring numbers. So in the previous video we talked a bunch about our divisibility rules. And we talked about how something is divisible by another number. Is it also a factor of that number? Or if something is divisible. So like if 20 is divisible by 4, then 20 is also going to be a multiple of 4, or 4 is a factor of 20. So just kind of getting the terminology there. Well, now we are going to be focusing solely on factoring numbers. And then on the next, I think it's on the next page, yes, we start talking about prime and composite numbers and also prime factorization, and then we'll look at factor pairs as well. And we look at factor pairs on this page. So we're going to check that out. So to find all of the factors of a number, you are going to need to find all numbers. So let me get my pen. Sorry, it's not working yet. I have to turn it on. To find all numbers that can divide into the original number without a remainder. Original number without a remainder. And then factor pairs. So you kind of heard me talking about that on the previous video. But factor pairs, it's going to be a pair of factors whose product gives you back the original number. So like 2 and 15 are a factor pair of 30. We would have more factor pairs of 32, right? So like we would say 30, if we were coming up with all the factor pairs, it would be like 1 and 30. 2 and 15, 3 and 10, 5 and 6. And then that would be your list of factor pairs. So in terms of like how can we factor, what can we use to factor, we're going to begin with 1, with the number 1. And we're going to check sequentially or check in order. So like just like what I did with 30, we're going to check with 1, and then it would be 1 and 30. So 30 divided by 1 gives you 30. Then we check with 2. Is it divisible by 2? And guess what? That's why we did our divisibility rules. So we would say, oh yeah, 30 is even. So it'll be divisible by 2. 30 divided by 2 is 15. How about 3? Well, is the sum of the digits is 3 plus 0. That's 3. 3 divided by 3. Yep, that's 1. So 30 is divisible by 3. 30 divided by 3 is 10. How about 5? Well, does it end in a 0 or a 5? Yep, it does. And then that gets you 6. And then once we like our next, if we were checking sequentially, it would be 6 and 5. Well, look at that. The pair here repeats. So we know we're done once we get to that point where our factor pairs are repeating themselves. So that's how we're going to go about finding all of our factor pairs. And then we're going to check sequentially. Using divisibility rules or trial and error. So you can do either one of these by division with numbers to follow. When we factor, so when you find a factor, find the other number in the factor pair. So that you won't end up repeating it later in the process. Then you want to keep checking the number sequentially until you reach the second number in the last factor pair. In the last factor pair that you found, or until the result of dividing gives you a number less than the number you just checked. So for example, like if we go back up here to this one, and we were writing 6, and then it's 5, this one is less than this one. So we know we're starting to repeat our factors. Or honestly, you look and you say, wait a second, I've already found this one. I've already found that factor pair. It's right here. So you don't need to rewrite it because it would just be repetitive to do that process. You don't need to do that. All right, so we're gonna find the factor pairs. Some of these we're gonna do together and some of these I'm gonna have you guys do on your own for them. So find the factor pairs. Let's do, we can do this first one together. So we're gonna find the factor pairs of 165. So I want you to write 165 and then you're gonna do a T chart here. And we're gonna do 1 and 165. We know it starts there. How about 2? Well, it's not even, right? So like it ends in a 5. So it's not going to be divisible by 2. If you would like to, you're more than welcome to do like 2 and then you can do like an X or something there. Or you just move on and then you write 3. Or you just check 3 in your head and you say, all right, sum of the digits. Sum of the digits, that would be 6 and 1 is 7, 7 and 5 is 12. Is 12 divisible by 3? Yes. So maybe you check quick. Okay, 165, let's do it. 165 divided by 3 is going to give us 55. And so you keep going. So you say, okay, how about 4? Nope, it's not even. So I'm going to point this out right now. If we know something's not even, we don't need to check any of the other even numbers. We don't need to do 4, 6, 8, 10, because if it's not divisible by 2, it's not going to be divisible by those other ones. So let's check 5. It does end in a 5, so we definitely know that it's going to be divisible by 5. You can do this one in your head if you want to. You can do it in a calculator, but 16 is divisible by 5 3 times. We'd have a remainder down, like, or not a remainder. Yes, let me just point it. This will be easier if I just do it. I can show you what I'm talking about. So we'd have 3, and then that would give us 15. Here's what I was talking about. We have 1 left over. We're going to bring down that 5. It gives you another 3, and that gives you a 0. So we're going to have 33 here. We know it's not divisible by 6. I'm going to give you a hint. We've got 1 more to find. So we know it's not divisible by 6. If you want to check 7, so you can do 165 divided by 7. It's not going to work. 165 divided by 8, we don't need to do it. 165 divided by 9, you can do your sum of your digits. 6 and 1 is 7, 7 and 5 is 12. Is 12 divisible by 9? No. And so then look to 10. It doesn't end in a 0, so it's not going to be divisible by 10. Also wasn't even to begin with. And then check 11. Is 165 divided by, or divisible by 11? And it ends up being yes. So 165 divisible by 11, it's going to go here, and then we're going to get 55, which is going to give us a 5. 55, we subtract that away, and it gets us 0. So our answer is 11 and 15. And then I'm going to tell you your hint here. This is what I would do if we were in class 2. That would be it. Those are all of our factor pairs. We have 4 pairs. We had, because this one is not one of our pairs. We have 1 and 165, 3 and 55, 5 and 33, and 11 and 15. On EdReady, be careful here. Sometimes they ask you to put them in sequential order. So they would want you to write 1, 3, 5, 11, 15, 33, 55, 165. If you don't put them in order, you get the problem wrong, and you don't want to miss that. So that's what you're going to do for 3. I want you guys to do 3 as well. You're going to do 50, and then you're going to split it up, and then you need to order them from least to greatest. And then same thing with 123. You're going to find those factor pairs, 123, and you're going to order them from least to greatest. And then I'll do number 2 here with you. So 48, we're going to have 1 and 48. And then it ends in an even number, so it'll be 2. And we'll have 24. And again, if you don't, like, that's just something I'm doing in my head, but if you don't know how to do that, you're welcome to do it on your calculator. You're also welcome to go like this, right? And so that's going to be 2. Then you're going to bring down the 8, and then that would go in 4 times. So you can do it that way too. So 3 is going to give us 16. And then 4 is going to give us 12. It's not divisible by 5 because it doesn't end in a 0 or a 5. We do get 6, and that's going to give us 8. It's not going to be divisible by 7 because 7 times 7 is 49. And then we get back to 8. right? So we get back to 8 and 6, and that repeats. So we're done at that point. And so we're going to get 1, 2, 3, 4, 6, 8, 12, 16, 24, 48, if we're kind of writing them down in sequential order. So I'm going to have you guys do 3 and 4 on your own. Just noting that. Sorry for my pause. And then we're going to look at the next page. I will give you a hint on those two, by the way. Number 3, you should have 3 pairs of factor pairs. So 3 factor pairs. And then on number 4, you should only have 2 pairs. That should be a huge hint. So you only get 2 pairs for here. And you're going to get 3 pairs for up there. And I'll make that note too. All right, on the next page, prime and composite numbers. We've got a definition of a prime number first. So a prime number is a number that has exactly 2 factors, like exactly 2 factors, not 1 factor, not 3 factors, exactly 2, 1 and itself. Or it's a number that is only divisible by 1 in itself is another way to think about that. So like the number 3, the number 3 is divisible. Like if we were to do a factor pair chart, it's divisible by only 1 and 3. But think about 4. 4, we've got 1 and 4, 2 and 2. And so our factors are actually 1, 2, and 4. We've got 3 factors. And so I've had people say, oh, that's going to be prime. It's not, because it's divisible by something more than just 1 in itself. So if it goes beyond that first row, it's not going to be a prime number. So then a composite number, it's going to be our next one. A composite number is a number that has more than 2 factors. That's an M. A terrible looking M. More than 2 factors. Note, you should highlight this, or you should do something important here with this line. Note the number 1 is considered neither prime nor composite, as its only factor is 1, right? 1 in itself, well, that would be 1 and 1. And that doesn't make sense. So it's neither. So here we are supposed to give these labels of prime, composite, or neither to these. And some of this I'm going to have you do on your own too. I'll do the first 3 with you, and then I'm going to have you guys do the rest on your own. And so 1 is considered neither again, because again, we've got this kind of definition and rule because it's divisible by 1 and 1. So only 1 factor. So it's neither. 5, what do you guys think? Should be prime. It's divisible only by 1 and itself. So again, if you were kind of doing like your factor chart, it's only by 1 and 5. Here, this is composite because we've got more than just those 2 factors. We've got 1 and 8 and 2 and 4. So that's composite. So I want you guys to do the rest of those 4 through 9, and see what you're coming up with. You should have an even number of, so you're going to have 3 more composites and 3 more primes. So 3 more composites and 3 more primes to get you through. So then prime factorization. So here's your another definition for you. So prime factorization of a number. It's when a number is written as a product of only prime numbers. So it's when it's written as a product. Again, that's an answer to a multiplication problem, right? A product of only prime numbers, often expressed using exponential notation. So that means something like this. Let's say we came down and we figured out the prime numbers of some number were like 2 times 3 times 5 times 3 times 2. And that was our answer. And so we would go, wait a second, I've got 2 2s and I've got 2 3s. So we would rewrite that product as 2 to the second power, because that exponential notation is repeated multiplication, right? So that means 2 times 2. And then we would write times 3 squared, because how many 3s do we have? We have 2 of them, which is where we get that exponent. And that's the same as times 3 times what's left is 5. And so you would have 2 squared times 3 squared times 5. Does that give us back what we started with? Absolutely. So that's what it's talking about when we rewrite it using exponential notation. So on these, we are going to do what's called prime factorization. Please, please, please make sure you understand and you remember the difference between prime factorization and factor pairs. So factor pairs is where we did that T-chart and we came up with all the factor pairs. Like if we did 15, we did 1 and 15, and we did 3 and 5. This is factor pairs. Oops. It was supposed to be factor pairs, not fact pairs. Factor pairs. And if we were doing prime factorization, that's putting it only as a product of its prime numbers. So you would say, how can I break that down? Well, we would break it down into 3 and 5. And this would be its prime factorization. Here's its prime factorization. And this side. And this is it written down as its factor pairs. So here we go. Number 40. We are going to do prime factorization. So pick any factor pair. Pick any factor pair you want. Oftentimes I'll have students do like 4 and 10. Okay, great. Let's do 4 and 10. So then we keep going until we break it down into only its factor, or only its prime numbers. So 2 and 2. Those are prime numbers. And we break this down into 2 and 5. We've got prime numbers all the way across. So I'm going to circle them so that I don't lose them. How many 2s do I have? I've got 3 of them. So I'm going to write 2 to the third times 5. And you can always double check, right? Like 2 to the third is 8. 8 times 5 gives me 40. Check. That gets me right back to where I started. So you just want to check. So this would be your answer, 2 to the third times 5. 53. Let's write it down into pick a factor pair of 53. And I'm hoping you're thinking about it, and I'm hoping you're like, wait a second, isn't that prime? And it is prime. So we would write 1 and 53, and guess what? All we write, because I'm hoping you remember, wait a second, 1 is neither. It's neither prime nor composite. So do not, I repeat, do not write it like this, because look at prime factorization. It is a number written as a product of only prime numbers. Well, this is neither prime nor composite, right? So what do we do in that case? We simply write the word prime for that. So you don't need to write it out as 1 times 53, because that would be wrong. We're just going to write the word prime underneath it. Okay, let's come down here to 42. Let's do 42. And maybe you're thinking about like 2 and 21, or you could do like 6 and 7. That's another one I get, 6 and 7. And then here we could do 3 and 7, and here we would do 2 and 3. And then you circle up your prime numbers. So see, it doesn't matter what factor pair you choose. You can do whatever you want. We're going to write it in sequential or ascending order, and it's going to be 2 times 3 times 7. And that's going to be your answer for that one. So I'm going to do 162, and then I'm going to let you guys do 5 and 6. So 162, I don't know, maybe we just do like, we divide it by 2. And so we'd get 81. So 2 and 81. And then maybe you want to do 9 and 9. And then we're going to do 3 and 3 and 3 and 3. So we're going to have a whole bunch of 3s. So then circle up your prime numbers. Don't forget that 2 at the top. And our final answer, we're going to start with that 2. It's going to be 2 times 3 to the 4th. And that's what you should get for that one. So 5 and 6, I want you guys to do those 2 on your own. And we are going to check out one more example on the back. Look at that, even says one more example. That's the title of it. We're going to check out the one more example on the back. Okay, let's do it. All right, it says, when finding a prime factorization of 72, Marie began a tree diagram using the 2 factors of 9 and 8. So I'm just going to write that up. So we've got 72, and we started a tree diagram, and we did 9 and 8. Classify each of the following statements as true or false. Justify your decision for each statement. All right, so Marie, so here's our basis, by the way, what's in black. So I'm going to add on these scenarios in different colors. So Marie started the tree diagram incorrectly, and she should have started the tree diagram using factors 2 and 36. So this one is saying, meh, wrong. You should have done 2 and 36 instead. What do you guys think? True, false, true or false? This is a big fat false. Does it matter what order or what factor pair we choose? No, it doesn't. So we're going to write in here false because Marie can choose any factor pair of 72, period. So false, because Marie can choose any factor pair of 72 to start her tree diagram. All right, let's go back up to our original thing. So we got to evaluate the next one, this next statement, to see if it's true or false. Marie's next set of factor pairs could be 3, 3, 2, and 4. True? Could that work? True. We're just going to point an arrow over there to show our work. All right, now I got to come back up. We're going to start with 72, 9, and 8. Okay, Marie's next set of factor pairs could be 3, 3, 9, and 8. I don't think so. Like, that doesn't work. So this is false. Because of that. Like, it's not 8 cannot be broken down into 9 and 8. So false, or you could say 9 and 8 are not factors of 8. That doesn't make any sense. So this is the part that's screwed up. Letter D. Marie didn't have to use a tree diagram. Do you have to use a tree diagram to come up with your prime factorization? No. There's other ways to do this. You don't always have to use a tree diagram. So this one is true. Other ways to solve same problem. Okay, that gets us to the very end of this very long topic. Thanks for tuning in.